In practically all of the problems we have solved so far, all of the examples we have seen, we have been dealing with information, right? We have been storing data and then processing that data in some way. How have we done that? Well, we used variables. And so far, every time we had a value, we have been storing it in a single variable. Suppose we have a business, we are writing the program for a business that deals with customers. And for some reason, we want to store the date of birth of different customers. Say we have customers A and B. How would we do that? Most likely, with what we know so far, we would create a variable, let's name it A, in which we would store the date of birth of customer 1, and then we would create a different variable, call it B, that we would store the date of birth of the second customer. Now, is that enough? Why would we like to have something more? We want to have something more because with problems, we want to be able to deal with problems on a bigger scale. So what are the kind of properties that we want to be able to have? We want to have ways to deal with data in bulk. What does that mean? If I want to have 1,000 customers instead of 2, I don't want to be going to my program and declaring 1,000 different variables so that I can store the date of birth of each of those customers. It will be much more convenient if I just had one variable and somehow I would be able to store all of those 1,000 date of births. Not only that, but also we want to be able to treat a collection of values as a single unit when we are processing it. I not only want to be able to declare a single variable so that I can then go ahead and store values, but also when I am writing, for example, a repetition structure, a loop, and I process the information, I want to equally have the ability to do it in a convenient way. For this reason, we have in our computer science life what we call data structures, or sometimes they're also called aggregate data types. What are those? Those are exactly the tools we need in order to accomplish the two major goals that we just mentioned. Arrays is just one example of those. We are going to see several others, and each of them have many interesting properties. What kind of characteristics do data structures have? When we are comparing different data structures, how do we know if one is better or worse than the other? Most times there is no data structure that is perfect for everything. They have benefits in one way or another. Here are the criteria based on which we compare them and based on which we decide which data structure to use. What kind of contents do we have? If the values that we're going to store have exactly the same type, then we're going to use a homogeneous data structure. Otherwise, we will need to store those values in a data structure that can hold heterogeneous data values. Not every single element will have the same type. How about the size? Before I start doing anything with data, do I already know how many data I will need to store and process? If that is the case, then a static data structure, a data structure for which I will declare at the very beginning its size and then never change it again, will suffice, will be exactly what I need. However, if the number of data values that I want to store may change in the future, I need a dynamic data structure. Finally, how can I access the elements? This is a very, very important point. When we have a data structure, we want to do 3 kinds of operations at least. We want to be able to insert a new element, we want to be able to delete an element, and we want to also be able to go and update the value of an existing element. How easy is it to do those things? And by easy in computer science, we usually mean how much time does it take in order for me to complete the required process. There are two ways that data structures allow us to access these elements: in a sequential way or a random access way. What do those words mean? Sequential means that if I want to, say, update the value of the fifth element in my data structure, I need to first go through elements 0, 1, 2, 3, 4, and then reach the fifth element. Excuse me, the element at position 5, which will be the sixth element if we start counting from index 0. In a random access, I don't have to waste my time going through the previous elements. The data structure gives me a way to just go and access exactly the element that I want without having to go through other elements first.